Hello to everyone again, and welcome to the GMI Zener versus Isolated Barrier webinar. I hope everybody's doing fine, especially during this crazy COVID period. Let's hope it gets over soon. As I said, we have a very busy class today, and a lot of questions have already been posed through the registration process. So we'll try to make it fit in 1 hour. I'm not sure we'll be able to. Keep in mind that during the entire seminar, you can make your question using the question and answer box. Anytime, just post a question in there and we will try to answer it as best as we can. Now, let me introduce you our host. Well, it is me, Paolo Landrini, and Andrea. Andrea is been with GMI for some time. He has a long experience in instrumentation, automation, and he's the right guy to be our panelist here. He has a lot of experience in intrinsic safety as long as automation and instrumentation, like I just said. Now we'll take just a few moments to introduce GMI, try to make it, to tell you who we are and what we do. Try to make it as fast as possible to save time for our question and answer session. GMI is all about safety. We are a safety company and we're committed to safety. We manufacture and engineer and design intrinsically safe and CE-certified devices in all applications, including automation, DCS, ESD, fire and gas, BMS, and all those packages in many industries. We have a long experience, over 40 years of experience, and we manufacture proudly here in Italy, although we are a global player. These are the products we manufacture: highest barrier, safety relays, isolators, power supplies, multiplexers, custom termination panels, hard multiplexers, SPD, surge protection device. We have indicators, and we also have a division that provides training and services in functional safety. And now we started with the EX training and services. These are our goal. Our goal is to have excellence. So we are a company that has lots of certification, including functional safety management, up to SEAL 3. We do invest a lot in R&D, and we try to be, leading the market rather than trailing the market. And let's say our social responsibility for us is important, because in the end, it makes a difference if the product is made in a certain way rather than, I got lost in my thought here, but rather than a low-class product. So our products are designed to provide safety in the plant, so we spend a lot of care to manufacture a high-quality product. And as I said, we are all over the world. So things local act global. So we have many subsidiaries, distributors, and we have done lots of installation around the world. These are a few of our customers. Basically all the Mac and EPC, OEMs, and end users. And here we are. I tried to make it very fast, very short, because it's not about the GMI today, but it's about intrinsic safety and Zener barrier versus isolated barrier. So I'll let Andrea take over for a presentation, and then we'll go on to the question and answer as they come along. Andrea?
Thanks, Paolo. Thanks for the quick presentation about GMI. So people, I think, like to know a little bit more about the topic of today, which is Zener and isolators. So let's go to the next slide.
Okay.
Wait, sorry. Okay. Explosive atmosphere, just a quick overview. It's hazardous area where there is a really combination of substances that is flammable, oxygen, which is always present, and there is a source of ignition that can generate the real explosion. So the famous triangle, I think a lot of you already seen that. So the combustible, the substances can be basically gas or dust. Okay, so most of the cases gas, but can be also vapor. So we know that oxygen is always present. So we have only one possibility due to the fact that we have a gas or dust in the area. We have only the possibility to avoid the explosion is to control the ignition. Okay. That it can be caused by the electrical apparatus, of course, by the energy that is given to the system. So in this case, any possible device that can be used in hazardous area must be compatible and really certified with the dangerousness of the area. Okay. So basically, the unit must be certified. That is the first information for today.
Great.
Okay. So there are different methods that how I can power and read signal in hazardous areas. This is the most known in the market, most used in the market. So there is segregation. It means encapsulation, means oil immersion or pressurization. There is the containment, that is a flame proof. Okay, so the big box you see in the middle, the big stainless steel box, or aluminum cased box. And there is the prevention, which is intrinsic safety or intrinsic safety, which is a topic of today. Okay, so let's go to the intrinsic safety. So we would say that intrinsic safety is the most flexible and the cost-effective solutions. Is used because it's really simple and low-cost solutions. And so the device that we mentioned in the first slide that must be used in the application is called intrinsically safe barrier or just barrier. Barrier is the most known name in the market. So the principle are here. So we are talking about low power application. So we are not talking about application where there is an engine, for instance. An engine consumes a lot of energy, needs a lot of power. So you cannot use an intrinsically safe solution in that case. We are talking about overrated components. There are safety factors that are influence the application. And the really important thing is isolation distances and the need of barrier to assure the system integrity. So the application here, we are talking about electronic instruments, probes, we are talking about sensors. So measurement and control processes, that is the market. And of course, where there is a battery supply devices. So low power systems. If you have any question, as Paolo said, don't use chat box, which is not permitted, is not allowed by us. Just a question and answer box. You see on the, I think, on the bottom part of your screen. So,
exactly.
Okay, the intrinsic safety loop is that. So just a slide that resumes what we said till now. So you have a simple apparatus, or IS apparatus, devices that are installed in the hazardous area. So it can be zone 0, zone 1, zone 2 also. And you have a safe area where there is a control room. So in this case, a connection between the control room and there is a DCS or PLCs is not permitted because of energy. So we say that we have to control the initial energies that goes from the safe area to the hazardous area. And the way to control is to use these barriers or intrinsic barriers or Zener barriers, which are installed in basically in safe areas and can power and read signal in a hazardous area. The way of do that is read by, let's say, controlling the energy in the hazardous area and giving an signal which is safe to the control room instrumentation. Okay, you can say that basically in the control room instrumentation there are DCS or PLCs already with intrinsically safe inputs. That's fine. But in case you don't have that, in most of the cases, you have to use those kind of hardware to interconnect the hazardous area to the safe area signals. So the associated apparatus, the unit can be Zener barriers. So the first product used in the market are passive devices that use Zener diodes to divert fault current to ground, or isolators. Isolators are active instruments and that within the unit, so there is a transformer and or optocouples that assure and keep out from the hazardous area any energy that can cause an explosion. So that is the difference between Zener and isolators. Oh, sorry, I skipped. And sorry, again. Okay, some troubles, can accept, I guess. So I would give you just this information about the different protection methods we just mentioned. So explosion-proof, intrinsic safety of pressurization. Those are the difference. So given that explosion-proof is safe, is flexible, has some installation cost values, and some maintenance cost. From this point of view, we would say that the purging is more safe, is more flexible, costs more at the level for installation, and have the same, more or less the same maintenance cost. However, intrinsic safety, you see here, is more safe because we are not talking, is controlling the energy, as we said, is more flexible. And the most important thing is also that installation is lower in cost and also maintenance is lower. It's I would say a light way to control the hazardous area applications, and also assure a live maintenance on application. We are talking about a live maintenance for application zone 0 also, of D1 for US also. So the most dangerous applications. So we want to give you some details about the circuitry in for Zener and the barriers.
Andrea, I see we already start having questions, but I think the question you will be answered those during your presentation. For example, they want to know about IS apparatus, what is an apparatus, who decides what is an apparatus, but this answer will come through the presentations. Continue.
And also for your information, during your, when you register yourself, we already made some questions. We already answered, and there will be a specific answer later on, okay? So don't ask anymore if you already...
If you wrote a question during the registration process, we have them all marked down and we will go through them, each one of them, after the presentation.
So this is the circuitry for Zener barriers. You see there is no isolation, but that's the normal. Huh? And is composed by diodes and resistors and the fuse. That is a simple circuit. You see that there is oh my God, I have to move my mouse. And the field sensor must be the most important things in the application, that the field sensor must require an isolation from ground, 500 volt minimum, and barrier must be connected to ground, 1 ohm maximum. So those are the most important precautions you have to take when you install and Zener barriers to protect an hazardous area circuitry. In this case, in case of fault, the voltage source will be laid directly to system ground without interfering with hazardous area. That is the topic on your, when you realize circuitry with the Zener barriers. The difference with the isolated barriers is that so the sensor, the field sensor, don't need any isolation from ground, and also the barrier, the isolators, don't need any connection with ground. Okay, don't need any. The 1 ohm was needed in Zener application is not needed for isolators. In this case, the voltage source will be laid directly to ground without interfering. Because here there is a safety transformer. There is isolators between the safe area and hazardous area. In case of faulty condition, what happens with the Zener barriers? It happens that if you have a poor isolation, if your sensor is isolated 500 volt, nothing happens. So your voltage will be led to the ground connection, the barrier ground connection. But if you have a poor isolation or short ground for the field sensor, in case of voltage fault, your voltage fault will be led to directly to the hazardous areas. Okay, so this is possible and is very dangerous in this case. In case for the isolated barriers, the sensor, as it can, is not needed, don't need any isolation from ground. The voltage lead will remain the safe area, as you can see.
Exactly, Andrea. These are the main difference between an isolated and a Zener barrier. There are several differences, but this is the most important. A Zener barrier requires a safety ground, requires a ground connection. And the ground connection, as shown here, has to be unique, has to be unipotential, has to be dedicated, has to be by standard less than 1 ohm. Because without this ground, the Zener barrier is floating and cannot divert fault to anywhere. In addition, as Andrea was saying, you need the isolation, because without isolation from ground, if you have more than 1 ground connection, then the fault can go to a different ground path, creating a problem. Sorry, I interrupted you, Andrea. Please continue.
No problem. It's fine. And this is the grounding that you have also to grant when you install a Zener barrier. So there is a safety ground for the barriers, can be also redundant safety ground. And also the ground for the enclosure where the field sensor is installed must be connected. This is a basic wiring. It happens also that sometimes that you have from fault current to ground from electrical motors, that this will this fault the hazardous area will go to the Zener barriers, and it is also a dangerous situation. A slide that give you details. So why galvanic isolators are more safe than Zener. Okay, so as we said, the isolator don't need any safety ground, so there is no cost for that. There is a better accuracy, because there is for the basically the diodes can have some leakage. Okay, there is a low installation cost, as we say. Don't need any the sensor don't need any ground, and the barrier itself, the isolator itself, don't need any earth connection. It's used for signal standardization, so 4 to 20 milliamps, contact or temperature, whatever. Okay, and as we said, you can use any kind of sensor without thinking, without checking if there is an isolation of 500 volt for the hazardous area. While the Zener needs dedicated safety ground costs require continuous checks, field sensor must be isolated, and there is the leakage for the, of course, for the diodes. So when you are talking, we are buying, we are using Zener, then isolator, you have always to check what is the cost for installation, because just the poor cost for the product is not enough, is not sufficient to say, to have an overall cost for the application, because there are a lot of related costs for the barrier, for the Zener, that sometimes are not took in account.
All right, Andrea. So we made the presentation short, so we could give you guys more time to answer your question. We have got 15, 16 questions, some of them quite tough, which we prepare reply to. Later, we will share copies of the presentations, both a question and answer presentation and the webinar presentation. So you have our contact details here. If you need to, to get in touch with us, you can do after. We also will post this on the webinar online, so you can review it and see all the mistakes we made today. There was a question here that I said was answered. Maybe I can clearly. He said, "What is IS Apparatus?" Well, IS Apparatus is a barrier. You have, sorry, IS Apparatus is a field device that is intrinsically certified, whereas associated apparatus is a barrier. Later we'll see, because there is a question, I believe, on this issue. And of course, these definitions are made by standards. It's not made by us or by the manufacturer. There is a standard, ICX standard, ATEX standard, that define all the names. Okay, so give us a second to stop this, share this presentation, and go to the next one. 1 second, with the question and answer. Okay, let's find the right one.
Paolo, there are some questions live, so or we start from the question we got from...
Yeah, you can see if there is, while I do this, you go ahead and look at those questions.
Okay, there is Johan that is asking, what scenario are there, if any, that we must use Zener barriers and not IS barriers? I think a scenario that Johan is mentioned is maybe what kind of maybe future Zener barriers will have.
Okay, let me look at the question myself. Are there family that must use it? Well, honestly, we have an answer for this during the seminar. We prepare a couple of slides, but basically, you can use both all the time, depending on the application. There might be some application where Zener barrier have not been developed for, or an isolated barrier may not have been developed for. The only limit on the Zener barrier is you cannot use it if the sensor is grounded. If you have a grounded sensor or a poorly isolated sensor, if this requires 500 volt of isolation, then you cannot use it Zener barrier. Answer live, we've done this, and then we say...
Yes, but not the question. Basically also Zener barriers are not really, really available in the market, not more as in the past, so they are not,
well,
stop making. So that is also a point. Maybe isolators, it's best option because assure better availability for the future, I guess.
Yeah, a lot of these questions I have answered already. So let me go to the presentation.
Okay, let's go to the standard question that we prepare from the.
Okay, let me get to the right place. Presentation PowerPoint. It should be this one. What you guys see?
Not yet, Paolo. Oh yes,
no. Okay, Andrea, remember to ask control so we can both take care of the presentation. Yeah. All right. So one of the first questions I picked up was, how do IS electronic works? Well, let me answer this one. You know, first of all, let's keep in mind that we are a manufacturer and there are a confidentiality issue here. Right? We cannot tell you how we do stuff. You know, IS is a very simple concept. And basically by selecting a few special components that are called infallible components, which means that they can fail safe. Take, for example, a resistor is used to limit current. This resistor can only be selected if the failure mode is open. It cannot fail short. So through the use of this component, you can limit, you use a Zener diode to limit the voltage, a resistor to limit current, a fuse to open a circuit, and a transformer or an optocoupler sometime to isolate this circuit. They're very simple components, but yet they need to adhere to very strict standards and they need to be tested. And not in a normal condition, but under the worst case scenario. There's a lot of more issues to be considered, like temperature, distances, clearance, equipalences, but you know, this gets into the R&D design team. So I will skip this and move forward to the next question. This question came from Pablo. Next question we had here. Let's see if I can take control of it. Okay. If a component of a system is IS, can the system be considered IS? If not, how to ensure the same? I don't want to mispronounce the name of the person who asked this question. It's very
then from Melody Beer. We hope we say it correctly. Maybe not.
Right. So Andrea, why don't you answer this question?
Yeah.
It was part of the presentation.
Yeah, exactly. So I would say that the answer is maybe no. Say that single components or also some components cannot make the system intrinsically safe. It is the complete system loop that needs to be considered totally. System concept where the entire system becomes assessed and certified as one unit, or I would say that system in this case can be assessed safe. For instance, we have our multiplexer for zone 1 that the single unit that is for zone 1, of course, a single, let's say, data acquisition cannot be used with, let's say, with the master, with the gateway that is not our gateway. So that's just an example, not for because of GMI, but just an example that in this case, the system is must be complete in order to be certified. So that is a system approach. And why there is, let's say, the entity concept where the field device, the cabling and the wiring and the isolator barriers or Zener, and are certified to be used with the system. So that is and certified to be used in that area, in that zone, and so on. So there are different approach. We see here that can be simple device. We can have thermocouple RTDO switches that don't need the certification. There are others that require certification. In this case, require certification when one of these values are higher than a certain number. In this case, if the voltage is higher than 1.5 volts, higher than 100 milliampere, or 25 milliwatt or 20 millijoule, sorry. In this case, if one of that is higher, the unit needs to be certified. It cannot be considered a simple device. Okay. And needed associated, of course, both simple devices, the IS apparatus, need an associated apparatus connected in the safer, the barriers, the Zener barriers, and the isolators. So you have another slide on that. Sorry.
Okay, you went forward. Let's go.
Okay. So in this case, you see that I'm pretty sure that any of you already seen those values, but there are some values that must be taken account when you are connecting and Zener barriers, of course, and isolators. And this is the value for the isolators or the barriers, and this is the value for the field instrument. So UO, IO, PO, and so on, UI, II, PI, CI, and so on. Okay, so you must verify that the values, especially for current, voltage, current, power, must be lower. The value for the isolators must be lower than the values, the same values for the field instruments. While the capacitance, inductance also must have some relations. Okay, but these are very, very important. And in the calculation, also the cables parameters have the effect, of course. So the length of the cable influence a lot the values for the capacitance and inductance, of course, for the cable. Now,
so basically, sorry, Andrea, it sounds very complex. I just want to mention, that having two systems, we have a concept where everything is certified as a block, and then entity concept where each device is certified as an individual device, and then you must put them together by verifying the safety parameter, which sounds complicated, and one might say to himself, why not do the system approach? Now, the system approach limits yourself. So when you have done a certification of a system, is that specific transmitter, that specific barrier, that specific device, and you cannot make any change to it. Whereas in the entity parameter approach, you can, as long as the parameter match, you can use any supplier or by any supply by any manufacturer. And in case of GMI, we try to make it easy. Let's see if I can slide the next slide over, or maybe you can try that. You can move the slide forward. Okay, here we are. We put online a tool, it's called EX Loop Verification Tool, where you can actually enter the parameters of your field device. The one for the barriers are automatically uploaded, and they will tell you okay or not okay. And everything depends on the length of the cable, which must be specified, and the type of instrument used. Of course, all has to be matched to the area classification. So depending on where you're going to install the barrier, where you're going to install the transmitter, these parameters change. It sounds complex, but it's not very much so. Also because as a manufacturer, all the manufacturers of safety barriers know what is in the field, know what instruments are available. So now we have a standardization of these parameters, are all basically the same. So 99% of the time, they are okay, unless you're talking very long distance. Okay, let's move forward. Otherwise, because we have a lot of other questions. Before I go to this question, I want to answer live a question here, Andrea.
Yeah.
They asked about Zener barrier grounding. We will have this later coming with another question, I believe. They say, if I have a Zener barrier, can I replace it with an isolated barrier? Yes. This is more easy than the other way around, because an isolated barrier does not require grounding, so you don't need to connect to the ground. And this answers another question, which says, can they be connected to the same ground? No, because the isolated barrier does not require grounding, as we saw earlier. So now another question came with from Manas, I believe. It was, what is the disadvantage of using a 102 isolated barrier or an 102 barrier combination? We call it splitter. Andrea, you can also take over this one. It's simple,
yeah.
but...
Yeah, we call it splitter. So here there are two examples for digital signal or for analog signal. In this case, we do have solutions. And there is say that a duplicator, or let's call it splitter. Splitter maybe is not the right words, but it's the known name. It's a really common practice. And when there is especially a revamping application project. And so it's a low-cost solution. And so you prefer, in this case, you send the same signal to two different loops for your data acquisition. So the values is divided in, let's say, it's repeating two outputs. Okay. And in this case, yes, introduce a single point failure. And the field device sometimes within the duplicator. So the units are completely independent. So we have two different channels in this case in the unit that are repeating two outputs. But in this case, as we said, we have a single failure point. So we have the loss of seal dependencies that is required, and the loop cannot be claimed anymore, 1 out of 2. So this is the main problem. Okay. So you reduce the cost, of course. It's a simple, because it's a simple retrofit on your existing applications, but is not anymore safe. It's not anymore seal, of course, in this case. And in our, let's say, in our application, we do have a unit, and in our hardware, we do have a unit that are independent. We do have dependent channels, complete dependent channel, that can be also seal-free independent channel. But by having that, you reduce the point of failure to the single sensor on the input. So that is the main things. Hope we answer to the question. There was an answer.
Yes, I think so, Andrea. Sorry, I was typing away some answer. Guys, I got disconnected to type answer.
There is a question maybe from Yelenko that is asking, what about the barriers for digital communication, for example, Modbus?
Of course, we have solution for Modbus. Later, we can show you that. Let's also move forward.
Yeah, maybe
somebody asked for vibration. Sorry, Andrea?
No, maybe there are two options for that. Not sure, because it can be if there is a Modbus output for some signal, that is the answer is yes. And also the answer is yes if you wanted to, if you have a Modbus that is coming from a Hazardous Area, you wanted to need a barrier to make it safe for the control system. And the answer is a yes also in that case. Maybe later on we will send you an email.
Yeah, we can show you maybe one of the products we have for Modbus application. But here's another question. For example, on a product itself, we had what about the application for vibration? Again, we have a solution for vibration, isolated. Of course, you can also use a Zener barrier. Yeah, maybe we did not mention earlier, I will mention at the end, but you know, GMI does not manufacture Zener barrier, just to be clear. There are basically today, isolated barriers are available for all applications and can replace Zener and with their limiting factors. Let's see. Okay, well, this is another question that was sent in the registration, which I believe we answered, but we can maybe clear this up because we already had 3 or 4 questions coming live for grounding. And the question, if the sensor element fails to ground, what are the consequences in a Zener barrier application? And another question was, Zener barrier can be used to interface ground the sensor. It's the same answer. And it is
we already answered to that.
Yeah, sure. We already answered, and you know, it's very clear, but Andrea, you can restate this.
Yeah. The installation, of course, is not safe, because in this case there are two paths to way where the fault voltage can go. So there are, it remains also in a safe area, but it is able to go to be driven, let's say, directly to the hazardous area, and that is the point. So,
and in this fault, I don't know if you guys see my mouse moving here. In this path, the fault current to hazardous location is moving to hazardous location without passing through the barrier. So there are no limit on the current, the voltage. This is why it cannot be done.
The Zener barrier is very dangerous in case, we repeat again, for poorly isolation, for field device poorly isolated. That is the main point. So once you want to use the Zener barriers, please make sure that your sensor is isolated from ground. Otherwise, make not safe the application.
Yeah, at the same time, this ground is the ground connection for the Zener barrier is a must. And we had a couple of questions. I answer typing. Basically, it is to be independent from any other ground. So basically, all the Zener barrier, all the IS barrier for Zener barrier has to be equipotential, so one, and has to go all the way to a ground road, which must be independent from the other. But later we see that this can also create some problem. Let's move forward. Okay. Can I install a Zener?
Yeah, Paolo, just a quick information about that, but about a question from Surinder that he said that he joined late and he asking for have this presentation PDF later. Yes.
Yeah, I already answered. We will send to all attendees. We will send the PDF of the presentation and the question and answer after the webinar. Grounding fault. No, sorry. A question came from. I don't remember now, but well, somebody sent an answer. Can I install Zener on an isolated barrier in classified area alongside a VFD or variable frequency drive? Well, yes and no. Why don't you pick it up, Andrea?
Yeah. Okay. So the answer, of course, is dependent on certification. So also the variable frequency drive or any kind of device must be suitable for the installation in that areas, and the certificate must say be clear for that devices. Of course, Zener barriers and isolators basically can be installed in zone 2, but also that must be, say, really stated on the marking in the certificate for the isolators of the barrier. So in this case, you must check the certificate. Also, other instruments can be certified for hazardous area installation. Okay. In case it's not certified, the unit or any electronic device that is not certified for hazardous area must be included in EXD, EXP inclusion. So, or any other suitable certified protection. So, if the product, just to recap, if the product is not suitable for hazardous area installation, they can be installed in the hazardous area installation if, let's say, included in this kind of boxes, protected boxes.
All right. Okay, so next question we have from Zelenko, I believe, and the question was a little difficult to understand. He said isolator for 816 milliamp DI. I believe, Zelenko, you were talking about line monitoring applications in DI, and because these are always a big issue. When you are using an isolated barrier to interface a digital input, you're basically interposing an isolation between the input and the output. So you're not seeing exactly the field, you're seeing a replication of the field switch. So field opened, you see an open contact. The field closed, you see a closed contact. But this implies that you might not be able to do line monitor to verify if the line is cut or shorted. So there are different solutions to this application. And this also comes to, there's a question also about Namur switch that we came online here. It said for vibration level, can I use Namur? What's a Namur different from normal IS? Well, Namur, as you can see here, is the standard that defines a set level of information. So you have, for open circuit, you have less than 0.1 milliamp. There are 4 values, I don't remember exactly the value, less than 0.1 milliamp, between 1 to 1.6 is open contact. Then you have close contact, 6 milliamp, above 18 milliamp is, below 1 milliamp is shorted and above 8 is open. So anyhow, it defines a set of information which you can see whether the contact is open, closed, or the line is shorted or was cut. To do this, you can use an isolator which repeats a Namur sensor. So take a Namur sensor input and gives a Namur sensor output. However, much depends on the card, the controller card that you guys are using. If you're using a ESD card that has line monitoring facility, then you can see this information. Some are Namur compatible, some are not Namur compatible. Some have designed their own sets of line monitoring information. That is why we have application where you can have an isolated barrier that transfer a signal, open, closed, through a set parameter of basically resistance. We fix the resistor value to match those of the DI card. So you have many, many versions to comply to a Yokogawa controller, to comply to Emerson controller, but basically you can transfer this information transparently. When you have a card that is non-line monitored, so cannot read this information, then you have to duplicate the signal. You can see in the third drawing here, and split the signal, one as your on-off and the second as alarm, and detect this through a second DI contact. I hope I was clear. I tried to move fast. The time is moving. Against.
There is one
question. A lot of questions coming.
Yeah, Paolo. There is from Koduba. What happens if some problem for us or hazardous happens in IS loop and fail? I think this is.
Yes, we have an answer to that later on, but yes, it's.
Possibly the answer is that. The barriers of the isolator is limited energy to the hazardous area. So it means that the level of energy I'm sending to the hazardous area is below the minimum initial energy in the hazardous area. So in case of fault, also the barrier itself limiting to the energy in order to avoid any initial. That is a problem.
Yeah, basically intrinsically safe means that it is safe, inherently safe. So when you use an IS solution, whatever you do in the field, you can short the wire, you can cut the wire, you can do whatever you want, and still the energy available will not be sufficient to ignite the gas mixture present. Of course, if you selected the right apparatus and the right associated apparatus for the gas group that you are working with, because it's a big difference between hydrogen and methane or propane. Next, are there any difference in the wiring between an isolator and Zener barrier? Well, basically,
the wiring. Can I answer, Paolo? The wiring is not. There are no difference. As you said, the main question is is in this case is that the field device need the isolation from ground, 500 volt, and earth connection for the Zener barrier. That is the most important the difference. But in terms of connection between the say the control system and the sensor and the barriers, nothing changed.
And here's some examples.
Yeah, some example, but the most important thing, as you can see here, there are a lot of blue area, not blue area. So, and it's the IS circuit and non-IS circuit must be separated by at least 50 millimeters.
5 centimeters.
Must have a special, let's say, cable tray, color differences. So it must be clear what is IS and what is non-IS. Your application.
Let me go back 1 second here. The Elenco said, was looking for digital input bearer for the instrument that, like a level switch that provide 8 to 16 milliamp. In this case, what you can do to do line monitoring application, you can use an analog bearer for a digital application. That is also always possible. If you take a 420 milliamp bearer, you can transfer the information from a DI within the limit of the analog bearer, which is typically 0 to 22 milliamp. So for example, some DI card can read this information correctly, some cannot, because they look at for a open circuit above 30, 40 milliamp, and an AI bearer will clamp at 22 milliamp, so they can never see open circuit. But it's a combination, between the field device, the bearer, and the analog or digital input card that you're going to use. Okay, let's move forward. We have a question about marking. This can be complex, but Andrea, try to be brief.
Yeah, this is the marking. Let's say that we have a directive marking, which is the main ATEX, and the standard mark, which is ICX. Okay, so briefly, so first is C, also for ATEX. Then there is the notify body, X mark. The second here, I hope you can see my mouse. Paolo, can you see my mouse? Yeah.
Yeah, it's my mouse, not your mouse. That's why I can lose my mouse once in a while.
Okay. Second means the different from mine. So there is a directive for mine application and non-mines application. So of course, mines is most critical application. Okay, so in this case, second means no different from mines. So for okay, there is a key payment category 1 in this case. So let's give you a quick overview about the difference. So 1G in this case means GA, as you see at the end of this marking. GA is for the ICEX application. 1G is for ATEX. So I think it means the same. So in this case, G stands for gas, and 1 is the most very high protections in this case. So it's the same like GA. If you see at the end, GA means gas, and A is most dangerous area for gas. Okay. So after there is EX, IA means a type of protection, in this case intrinsically safe. Second C is the gas group, and the T4 is the level of temperature, can be from 1 to 6. In some marking, you can see also the bracket, okay, the bracket, and means that itself, maybe the unit can be installed in some area, but it can be connected to the most dangerous areas. So the bracket means where the unit can be connected. It's further information. So there are, if we see, if you look at our product, there are a lot of marking because unit can be used in different applications.
All right. We still have a lot of questions coming on earthing, and let me answer a couple of those here live, because if I start typing, I get too close to my computer. They say in a refinery we're using some barriers, and the marshalling cabinet have different earth for IS, non-IS, and electrical. This is the right way. They all have to be independent. Then we have a question which is quite interesting, and it's about, it says field transmitter shield connected on transmitter, but in JB main cable shield is connected to JB ground. JB ground is connected to earth. which may be connected to electrical grid, which fetch some failure of bearing in panel. Upon checking, panel ground shows inconsistent voltage. Okay, let's start by saying this. If you have a shield, the wiring of the shield should be grounded only at one location. You cannot ground the shield in two locations. This is for IS rules, so you can ground it in the field or in the control room panel. They have to be floating on one end. Otherwise, you can run into this issue because then the ground becomes a ground path, it becomes a wire that is uncontrolled by any barrier across the hazardous location. All right, let's hope I answered that, and let's do this done. Okay, Andrea, let's move forward to the next question that we had scheduled for. Well, this is the tough one. Do we still have time? Yes. Let me see if I can answer this. I've done a little research myself on this because we are not an SPD surge protection device aspect, in the sense we manufacture SPD as complement to our IS barrier for installation in the control room. We do not have a complete range of SPD, but for IS application, I believe I can answer this question. So the question is, can SPD be replaced by an isolator? Are any effect of grounding on the measurement? And why there are floating ground issues? Well, first of all, an SPD is designed to protect from the field to the control room. Okay? Instead, a safety barrier is designed to do the very opposite. In addition, an SPD can protect from a very high voltage, kilovolt, 10 kilovolts, some are 20 kilovolt, whereas a safety barrier is designed to limit voltage at max, very much less. And it's inherently, the barrier is not designed to do surge protection, but it can act as a surge protector within the limit of the barrier. So the barrier typically at 1.5, 2.5 kilo of isolation. If you have a surge coming back from the field, up to that level, the barrier will protect what is behind that, so the PLC. But for sure, the barrier will be destroyed. It cannot be protected. Whereas in the same way as SPD. The grounding, all the grounding, this come back to the same question we have earlier, all the grounding must be independent. And to avoid any grounding floating issues, they have to be equipotential. So the 3 ground that you might have, the 4 ground, the IS ground, the SPD ground, the electrical ground, they all have to be independent, go to a ground rod, but to avoid any raising of the voltage between the grounds, you have to make it equipotential. This is very difficult to have equipotential grounding at different locations. So there exist devices that allow this to do. There are like switches which will temporarily make the equipotential ground in case of a high voltage, in case of a fault. I hope I answered that. Let's see. Any big issues? Okay. Look on.
From your there is a nice questions. So it is okay. IS barriers and IS sensors of different approval bodies.
Yes, of course. Of course, this is the
IS barrier is
concept.
sensor is CSA approved. Yeah.
Well, depends which standard they are approved to. You can the bodies, each laboratory or entity can certify it according to different standards. For example, CSA can issue an ICX certificate or can issue a CSA or a UL certificate, okay? So it depends on the certification. Each certificate states which standard they comply to, they adhere to, and you can, as long as you're talking apple to apple, you can take certificate from different bodies, TUV, DECRA.
Yeah, but in this case, you have to match the parameters. So if the parameters are, let's say, the UI, you remember, UI, UO.
If you cannot, this is a question we would have to pose to our certification expert, Roberto, who is not here today with us. But now my belief is if you have a CSA approved device according to CSA standards, okay, for North American installation, and now you take a barrier which is ATEC certified for European standards, theoretically, the two standards are very much the same, but there are differences. For example, class and division. In Europe, we define the areas as zone 0, zone 1, and zone 2. In America, they define the areas division 1 and division 2. The division 1 includes zone 0 and zone 1. So there are differences. So the two cannot be matched easily. But however, you might have a CSA certificate issued according to ATEX standard, and the installation is according to ATEX standard, then there is no issue with which laboratory has issued the certification. Is that clear, Andrea?
Yeah.
Okay, great.
Let's go to, maybe
it's
already 1 hour, Paolo. So
we are in 1 hour. What do you think, guys? Can we go on? We should put a poll out there, but it will take time to create a poll and send you the poll. We give another 10 minutes. Whoever wants to stay with us, we continue. We have
other 4 or 5 questions. So we want to
4 or 5 questions that came in. We can answer. Let's move forward. The one is how easy to, Andrea, how easy is to select an isolated barrier versus a Zener barrier? Are isolated barrier more complex to select or the same as Zener barrier?
So the isolated barrier needs more details to be, let's say, for the IO required. But also, if you look at this table, also the Zener barriers needs to be really, let's say, calculus that you need the parameters of the sensor you are using in that case. So it's not easy to choose also a Zener barrier. It's not really easy. We would say that isolator barriers are more standardized. So you can have isolator barriers with mostly universal for all temperature sensor, for all milliamps of voltage. So in this case, is easy for people using an isolated barriers. And there are some applications, of course, you have to check if you're using maybe some encoders, some antennas, and so on in that case. But basically, I would say that isolated barriers is more the simplest way to use.
Yeah, basically, you know, isolated barriers come in so many varieties that can be selected for any application. Of course, you need to know what is the application, but it's very much the same for Zener barrier today.
It used to be so much from this table, but that is the parameters required when you want to use.
Here is, for example, a list of the GMI barriers that are available. You can see there are many: analog input, analog output, digital input, digital output, universal temperature device, specialty barrier. As we discussed earlier, we have vibration, strain gauge, frequency, RS485, Modbus. So there's always a solution, but in a very, very, very few cases where isolated Zener barrier are used. And I answered that question, one of the last, in the recap, in the last question. And a question came about seal. What is seal important in IS barrier? I believe so. Andrea, you want to answer? Yeah, go ahead.
Very much in that.
Yes, it's very, you know, it's important because honestly, today all the barriers are seal certified. Correct? And you can see here there are several advantages. First of all, a seal certified device gives you a known failure rate, so you know how reliable that component is. And it is typically has redundancy, built-in redundancy to provide for a better component. To reach a seal 3 level, you have to use better components than a standard product. So in the end, you get a better product. You also have certification that guarantees the performance, the manufacturing, the design. The entire process is controlled, which is called systematic capability. Not only the components is sealed, but also the company that designed that product. you have extended life expectancy, and there's lots of products today are available for seal. You want to add something, Andrea?
Yeah, I would say that, of course, seal is not really a law like ATEX, which is a law, is a norm. So we decide to use, to follow or not follow. We decide to follow, and this really, as Paolo said, it's granting much more reliability for the product. And so better components, better specification, known failure rate, and so on. That is, let's say, warranty for your also IS application. If also the seal is not required, because there are a lot of applications where seal is not required. But in this case, if you take seal, you have something on your paper that declares the device is more reliable.
Yeah, basically, you know, a better product is a better product. And today, it does not come as at a cost disadvantage, you know. A barrier has to be reliable because it has to provide for safety. So it has to be reliable because you must be reliable. Therefore, to make it a seal certified device was not so difficult. We have a few questions here that might take some time. I want to skip, Andrea, to one of the last questions, and then maybe we come back if we have some time. So you guys bear with me if I run through some slides fast, but I want to give you a recap of the situation. This question came from a few of you guys, was the pros and cons, the cost difference, the maintenance issues, the trend of isolated versus Zener barrier. Well, we try to answer this in this slide. Andrea has very clearly defined earlier the pros and cons of isolated versus Zener. Basically, you know, you have all the installation issue, the grounding issue, and so on. But are there other aspects? Yes. You, Andrea, wanted to answer this, or you want me to do it?
Yeah, of course. Yes, I was writing to answer. I was writing some.
Yes, you're typing off. Don't worry, you type off the answer, and I finish this up.
Yeah. Okay.
Basically, the cost difference is minimum. Sometimes can be opposite of what you expect. When you look at item per item, you buy a Zener barrier. Typically, you need a double Zener barrier because you have two wires, so you need two paths of protection. Versus an isolated barrier, the cost difference is there sometimes. So an analog barrier isolated might cost more than a Zener barrier. Whereas a digital barrier isolated might cost less than a Zener barrier. But in general, you might believe that the Zener barrier is less expensive. But when you take into account, as earlier Andrea explained, the CapEx overall cost, so the grounding that you have to create for it, and the maintenance of the grounding, because this grounding must be by standard inspected, verified. To do so, you have to have a redundant ground connection, because if you disconnect ground, you're no longer safe. So how can you check the ground without disconnecting it? Well, you either shut down or you have to have redundant ground. So these are costs, the wiring cost, the grounding cost that goes beyond the cost of the item, which must be taken into consideration. Also, when you look at multiple channel isolated barriers, there are dual channel, 4-channel, 8-channel barriers. In this case, the cost of an isolated barrier is much less than that of a Zener barrier, which is, you know, by standard defined. It cannot change. It's as a fixed cost. So
also we have features that one guy, I cannot remember the name of the guy that asked, maybe was Yelenko, Modbus. There are some solutions within our portfolio that is giving the Modbus output. So you can connect different sensors in your application. You can isolate it, of course, and you can get the data through Modbus interface. So it's another way that that isolator
and you avoid the grounding issues of the Zener barrier.
So Zener barriers, you cannot have this kind of advantage.
Yeah. Also, the another point that we're trying to make a pros and cons is the headache that typically are associated with Zener because anything that happens, any voltage fluctuation, even a simple mistake like shorting the wire, will cause a Zener to blow because that is what they're designed for. And blow means replacement. An isolated barrier is inherently much more resilient. You can short the wire, you can reverse the wire. You need a lot of voltage before you blow a fuse into a Zener barrier. Okay? You have to go above 250 volts. So they're inherently more safe. Not more safe, well, in a way they are also more safe, but they are more resilient. So they give you less problem in maintenance. Last, the question was about trend. And at least this is my experience. Andrea can give you his experience in Europe. I have experience globally. The trend is isolated barrier 90–95% because of the issue we discussed. Where do you see application for Zener barrier? Some special
sensor.
OEM sensor, some special application where an isolated barrier was never designed for and is very limited application, so the cost of design it is not worth it. Or when you have a project where you have many Zener barriers installed, well, then they keep blowing and you have to keep replacing, and then is a potential for that. But this is typically done replacing the existing. New project, in my experience now, the last 10 years, I have not seen a new project requesting Zener barrier. How about you, Andrea?
I think in Europe is even better from this point of view. So nobody asking for Zener barrier, except for replacing, except for some revamping, but not new project for sure.
Okay, I see that we have a few participants are still there. We have still 80% of the participants. Let me go back to...
Yeah, let's finish with the last one, Paolo, and otherwise we go...
Okay, let's finish with this last one. The last one was, a lot of you asked about if we were to arrange a webinar on safety relays. GMI is preparing lots of webinars, including safety relay. One is coming up very soon, safety relay. Andrea, when is that due?
Next Tuesday.
Next Tuesday.
Yes,
I recommend you look up our website. We have a live webinar schedule. You know, just go to our website, go under, I don't know where, but it's support, I believe, live webinars, and you can see the schedule. We go on 1 hour and 50 minutes. I think is more than enough. We thank you for listening to us.
Thank you very much.
Yes. Thank you much. Anything you want to ask again, you will receive a copy of the presentation. In the presentation, you have my email, Andrea's email. Please feel free to write to us. Thank you again.
Thank you very much.